We've talked about parallel lines and transversals. Okay? We know if that line is parallel to that line, and there is any kind of a transversal, then this angle 1 and this angle 2 are supplementary to one another. And every other angle you see there, in other words, angle 1 is the obtuse, angle 2 is the acute angle. So this is obtuse, that's the same as angle 1, that's the same as angle 2, that's the same as angle 1, that's the same as angle 2, and so forth and so on. And that is true as long as those two lines are parallel. Well, the reverse of that is also a theorem. In other words, if I don't know these lines are parallel, but you tell me that angle 1 is the same as this angle 1, that's all I need to know that those two are parallel. In other words, these have to be parallel as long as this angle is equal to that angle. A lot of geometry theorems are like that. You have a geometry theorem that says something, and it's called the corollary, is also true. Well, if we look at this problem, they're telling us that angle x is equal to angle y. Now, they're also telling us that this angle is 90 degrees, which makes y 90 degrees. It makes x 90 degrees, and it makes this angle 90 degrees. So, the fact that this angle here is the same as y means that L2 is parallel to L3 by definition.
Okay.
Okay? Now, it says, so this part is true. Line 1 is perpendicular, that's what this thing means, is perpendicular, meaning that it's going to form a 90-degree angle. Well, as long as I know that x is equal to y, and that y is 90 degrees, then x has to be 90 degrees. And if x is 90 degrees, then line 1 is perpendicular to line 2. So the second part is true. The third part's a little bit strange. Any line that intersects line 1 also intersects line 2.
No.
No, clearly we can see, well, line 3 intersects line 1.
It doesn't intersect.
But it's not ever going to intersect line 2 because they're parallel.
All right.
So it's 1 and 2 only. Be able to draw a picture here. This is a V. V is equal to 2W.
Okay.
Boy, it sure doesn't look like it, does it? In fact, it looks like V is smaller than W. So the first thing we know is that we can't really use the picture. We have to use math here. W is equal to 2x. That looks right. And x is equal to y over 3. Well, what's the value of y? What kind of an equation can I write here? Just looking at this alone without any of this information, what equation would you be able to write?
Equal to 180.
V plus W plus X plus Y, indeed, is equal to 180. Okay. Now, since they're asking about y, what we'd really like to do is put every other variable in terms of y, right? In other words, I can't solve this as is. I've got 4 variables and only one equation. But they give us this extra information here. For instance, x equals y over 3. So let's substitute for x. Let's put y over 3. W is equal to 2x. So can I write w in terms of y? If w is equal to 2x and x was equal to y over 3, what is w in terms of y?
2y over 3.
Good. So I'm going to substitute that for w. And then v is equal to 2w. So if v is equal to 2w, how many y's is v?
4.
4y over 3, correct? Well, now we've got one equation and only one unknown. How are we going to solve this? What's the quickest first step towards solving an equation that has a bunch of denominators?
Multiply.
Okay, so I want to multiply both sides by 3. What do I get on the left when I multiply the entire left side by 3? In other words, I'm going to do this, which means I've got to multiply every term by 3. And then I'm going to do this. I'm going to multiply this one also by 3. So what's this first term going to be?
12y to the third.
No, let's cancel before we multiply. In other words, it's definitely 12y over 3. But I can cancel that 3 with that 3. That's what I got left is 4y.
So 4y plus y.
What's the second term going to be?
2y.
Did you say 2y?
Yeah, 2y.
Okay. The third term?
Y.
And the fourth term?
Y.
No.
Or 3y.
Plus 3y. In other words, it doesn't have a denominator.
Yeah.
And then 3 times 180 is 540. Now, much easier equation to solve because there's no denominators. Always try to get rid of your denominators and your parentheses. That's kind of the game plan towards solving equations. How many y's do I have on the left?
4. Or
add them up. What's 4y plus 2y plus y plus 3y?
6, 7, 10.
10y. 10y equals 540. Y is equal to 54. Let's look at number 9. Now, I'm going to draw this one just because it's easier to see if I can talk about it. This is supposed to go through the origin. Okay, let me number these instead of lettering them. Just because it's easier to talk about. Which angles are equal? Which angle is equal to 1?
Aren't they all equal angles?
No, hold on. Let me draw this just a little bit better. Jeez. Hold on. Okay. They're not actually all equal. There's nothing in the problem that says that any of them are equal to the other ones. But there's a couple of geometry principles at play. Remember that if you take any two lines and cross them, then that angle is equal to that angle, and that angle is equal to that angle. They're called vertical angles. Okay? So what angle is equal to 1?
5.
2?
5.
What's the vertical angle to 2?
Oh, 6.
Uh-huh. 3 is the same as 7. 4 is the same as 8. In other words, sometimes in your mind you have to be able to eliminate some of the lines in order to see it. In other words, 1 is the same as 5 because if I just drew that line and that line, they'd be the only lines there. They would cross, and so 1 is equal to 5. Okay, so which 4 angles have to be equal to 180? We know that 8, 1, 2, and 3 are equal to 180, right?
Mm-hmm.
And 1, 2, 3, and 4 are equal to 180. And 3, 4, 5, and 6. So let's look at A, B, E, and H. A, B, E, and H. Well, A is the same as E, but I don't think we can say that A, B, E, and H are equal to 180. B, E, G, and H. B, E, G, and H. Are those supplementary?
No.
Notice that 2, 3, 4, and 5 are supplementary, right?
Mm-hmm.
Well, we've got 2 and 5. Question is 3 the same as 7, or G, and is 4 the same as H? And the answer is yes, they are. So when I have 2, 3, 4, and 5, it's the same as having 2, 8, 7, and 5. You get that?
Mm-hmm.
Okay. So that one is supplementary. They do add to 180. A, B, D, and G. Well, A, B, D, and C would be supplementary. And C is the same as what?
G.
Did you say G?
Yeah.
So A, B, G, and D also add to 180.
All right.
All right. Parallel lines again. All 3 of those crossing lines are parallel.
Mm-hmm.
So they want the value of A plus B plus C plus D plus E. Well, what's the value of A plus B?
180.
Good. What's the value of C plus D?
180.
And what's the value of E?
G. I don't know.
We don't know. So A plus B plus C plus D totals 360, but E could be anything. In other words, I could draw this picture. The thing to notice here is that if I drew the picture like this and made that angle just a little steeper, I still have a plus b plus c plus d equal to 360, and e is different now. E is closer to 90 than it is in this picture. So the fact that I can draw this picture in a different way means that E could be anything, and it doesn't mean we can't figure out what it is. So the answer is it cannot be determined. All right. 38. Let's see. We want to go next, not to advanced. 149. Let's go to triangles. Now, most triangle problems that you're going to be confronted with, you always have to figure out something else before you can figure out the answer directly. Okay? So they've told us this is 60. And this is x, and this is 40. And they want to know what x is. Any ideas?
No clue.
Well, go back to that vertical angle theorem. In other words, whenever you have two crossing lines,
Oh,
okay, so what angles do we know here? Do we know what this angle is?
40 degrees,
Do we know what this angle is?
60 degrees,
And do we know what this angle is?
X. Or we don't know.
Well, you're right. No, x is the correct answer. And now do we know what x is?
No.
Sum of the angles of a triangle have to add to what?
180.
180. 180 is the magic number in
80 degrees.
geometry. Exactly. In other words, you're always subtracting stuff from 180. What's this x? What's this angle here? Can you see where my hand is placed?
Yeah, I see where it is.
Yeah.
I don't know.
What's the sum of the angles of the triangle equal?
Oh, like 180.
So what's that angle there?
100 degrees.
180 minus 60.
Oh, 110.
120. 120. 180 minus the sum of those two, which is 60, which is 120, which is the answer. Which brings up another geometry theorem that's worth memorizing, and that is, this is called an alternate exterior angle. Okay? Well, an alternate exterior angle is always equal to the sum of the other two angles that it's not next to. Because x has to be supplementary to this angle, and this angle has to be supplementary to the sum of these two. Therefore, x has to equal those two. 120 is what this angle is, making this angle 60. And we could have gotten there a little more directly if we knew this theorem. That an alternate exterior angle is equal to the sum of the other two interior angles. In this figure, what is x?
Not sure.
What's this angle right here? Remember that in these triangle problems, you always got to figure out something else. Never,
70?
you're never going to be able to figure it out immediately.
70?
This is 70.
Yeah.
So
70.
what is x now? If this one's 70?
50?
Yep. Well, no. It's got to be the sum of this one and this one. So if this is 70, then x has to be 130. Notice that if I draw this, if this is 110 and this is 60, well, this is 70 because these two are supplementary. This one has to be 50 because the sum of the angles have to add to 180. And then x is supplementary with the 50. So x is going to be 130. And notice also that that's the same as the sum of this 60 and that 70. This alternate exterior angle theorem. If I label that 50, notice that this 110 is the sum of 60 and 50. What's x in this one? Now there's actually three triangles in this drawing. There's this triangle, there's this triangle, and then there's ABC triangle. And you need to be able to view it, all three triangles, to solve it.
All right.
What's angle ABC equal to? Not x, but angle ABC. By looking at the biggest triangle there, what is it equal to?
90 degrees.
This is 30. That's 50.
Oh.
What's that big angle got to be equal to?
Oh. 100?
Okay, now if that whole thing is 100, what is x?
45?
You got it. Let me make that just a little bit bigger. BD bisects ABC. That's what this says. Okay? What it means when a line bisects an angle is that angle ABD is equal to angle DBC. Right? This angle right there is equal to that angle right there.
Okay.
What's the entire angle equal to?
100.
So what is each angle equal to? If they're equal.
They're both equal?
Yeah, when it says that BD bisects ABC, that means that that angle right there is equal to that angle right there.
Oh, so it would just be 50%. 50 degrees.
50 degrees. Each of them is 50, but the question wants BDC. So if this is 50, what is BDC?
100?
Correct.
Or 90?
No,
It has
100.
to be 100 because it's 80.
100. Make sure they always add up to 180. This one, they want PTR, this big angle up here. The combination of these two little angles.
All right.
So, let's see. Always remember that you're going to have to figure out something else first. So let me draw this. This one's 110. This one's 140. Let me label it and tell me what you can label. By letters. Do you know what angle TRQ is?
TRQ.
TRQ. This angle.
Oh, so that one right there would be 40.
Okay. Now how about RTQ?
RTQ.
This one up here.
Okay, so that'd be 30 degrees.
Okay. We know this one is 50.
And ATQ is 60 degrees.
What's TQP? This one right here?
TQP.
It's supplementary with that 110.
Oh, so 70.
Okay. And what's this one right here?
60.
So the angle they want is 90. PTR. It's the sum of these two here. All right. That's probably a good place to stop. We can pick up at number 7 next time.
All right, sounds good.
All right, Cole. Have a good week. Talk to you next Monday.
Talk to you next Monday.
Bye-bye.